Let's take a look at our lesson on complex numbers. Let's focus for just a moment on standard form. So this is standard form for complex numbers, and as you can see in this diagram, complex numbers really describe all numbers. Different types of numbers are within complex numbers, the real numbers, rational. You're probably familiar with those words, but for real numbers, basically b would equal to 0 for real numbers. Okay. So that's standard form for a complex number. Let's look at the imaginary portions. Let's look at kind of focus on imaginary numbers. So this is kind of just something you have to memorize. There's not really a way to make sense of it besides memorizing it. So we know that I is equal to the square root of -1. So that means that when we see the square root of -1, we can replace that with I. And I is just the lowercase I. It stands for imaginary unit. Now, there are some problems that ask us to deal with powers of I, I to the first, second, third, fourth. And there really are two different ways that you could approach problems like this. One way would be to memorize the pattern. And then apply the pattern. You would apply it to the new problem. So in other words, it's always going to go I, -1, -I1 powers, and then it's going to repeat itself. So I to the 5th would be I, and so forth. So you can, if you're really good with patterns and you really like patterns, then that is certainly a way that you can deal with the questions that ask you to do powers of I. The second way is to write everything in terms of I squared, because I squared is -1. And so that just kind of helps us. It's just a second way to do this. So I'm actually going to kind of focus on the second way, writing everything in terms of I squared. If you want to work through patterns, then please go right ahead. But I'm going to focus on the second technique. And so what we would do is we would write everything, in terms of I squared. So let's see for a second. I know I squared would be I to the 4th, and then we would need an additional I to give us I to the 5th. So that gives us I to the 5th is the same as I times I squared squared. So we replace I squared with a -1, and -1 squared is 1. So I to the 5th is the same thing as I, which we would have gotten had we done the pattern up here. I to the 5th would just start over at I. Okay, so let's look at our second example. Let's see, so we're going to do the I squared to the, 2 times 31 would give us 62, and we don't have any left over. Okay, so that's looking good. So basically we have -1 raised to the 31st power, and we know if -1 is raised to an odd power, then the result is going to be -1. Okay, we're doing good so far. So this negative exponent, perhaps you remember how to rewrite things. We would have to rewrite this first. And so this is the same thing as 1 over I squared. That's what I to the -2 would be. And so now we just deal with, the 1 is just bring that over. Let's see, I squared we said was a -1. And so our final answer on this, 1 over -1, is just -1. So those are some examples on dealing with I to different powers. So let's just kind of, take this a little bit further, and let's keep working with other examples with I, and this time things are being squared. So this is an important distinction between these two problems. Notice that in the first problem, the squared is just attached to the I, and in the second problem, these parentheses force the squared to be to both the 2 and the I. So let's just start with our first one. So we know that I squared is -1, and so this would turn out to be -2. Okay. Then we're looking at this one. We need to clear the parentheses first. So this is 2 squared I squared. Okay, so that would give me 4, and we just said I squared is -1. That's just something we kind of need to memorize. And so this would give me a -4 is my answer. Okay. All right, so our next one with the squared, so let's again, this parenthesis tells us that the squared, this distributes to everything inside. Remember, because they're being attached by multiplication, that is not a thing if they were being added together. I can't even find enough opportunities to say that, because that's something students make mistakes on frequently. So it has to be attached by multiplication, then we can distribute the squared in there. So this would be I squared, square root of 2 squared. Okay, so I squared is a -1, and the square root of 2 squared is 2, so that would give us a -2. Okay, great. A couple more problems before we move on to the next page. And here what I'd like to do is to look at these simplifications up here. We see that the square root of -a is I root a, so just a simplification of it. So let's go through the steps. What would we have done? Well, this would have been square root of -1 times the square root of a. That's what that would be. And so we know, because of this piece of information, that the square root of -1 is I. So that's why the result of this would be I times root a. Okay, and this, we actually just did a problem like this where this was distributed, and it gave us I squared, the square root of a squared is a, and we know I squared is -1. That's what gives us that result. One other thing that I need to talk about before we do these problems here is this whole square rooting thing. And so this is something that some teachers don't really focus on, which is fine, but I would like to investigate what is the square root of x squared, what does it equal, and we know, like, just thinking it through, it's x, right? That's what we know, but it's only true, this only is true for x is greater than or equal to 0. That's the only time that's true. So for example, I'm just setting up the logic behind why we're getting ready to do what I'm getting ready to show you that we're going to do. So the restriction here, where x has to be greater than or equal to 0, actually causes a little bit of trouble, because this, for example, if x was, say -2, we can see that these two don't equal each other, right? They don't equal each other. You can't have a square root equal to a negative number like that. So that's why that first example, that this only works if x is greater than or equal to 0. So what would we do? What would we do to make sure it works all the time? Well, what we would do is we would add these absolute value bars. This is true all the time. mean, for real numbers. That's true all the time. Okay, so just kind of throwing that out there because we're getting ready to do some simplifications that might seem a little weird. So keep in mind, if it's an even power underneath the radical, an even power, then it comes out as absolute value of x, or whichever one it is. Okay, if it's squared, it comes out as absolute value of x. Okay, so let's simplify. So this right here is I, right? The square root of -1 is I. That is an I. This, I don't know if you remember from previous math classes, I love factor trees. That's how I would deal with the numbers. So we know the square root of 9 is 3, and so that's good. So this is going to give us a 3 from the 9. It's going to give us the square root of x squared is absolute value of x. And then I've got the I, that square root of -1 is I. And then the 2, poor little 2, has to be left inside. Now, what would happen if you forgot to put the absolute value bars around the x? Well, for a lot of teachers, I mean, that wouldn't be an issue, right? But it is an important concept in calculus and in upper level math. So it's kind of something to get in our heads, you know, kind of thinking through that and making that's the normal thing that we would do, is if we do the square root of x squared, we would get absolute value of x. All right, so let's look at our next one. And we've got this comes out as I. The 32, again, I like to do factor trees. Okay, so that's good. This, we can kind of do a factor tree on x to the 6th if you want to. What would that be? That would be y cubed times y cubed. All right, remember when we multiply common bases together, we add the exponents. So that's kind of breaking it all down for us so we can get a feel for what's going on. All right, so let's work this through. So this negative is negative. That just comes down as a negative. Then the square root of -1 is I. And then we know that the square root of 16 is 4. Let's see, and then we've got a y cubed that comes out, and that's an odd number. Cubed is odd, so we need to make sure that we keep it positive, because if it was underneath there, it would be positive. So if we bring it out from under the radical, it also has to be positive. And then let's see, what do we have left inside? We've got the 2 and the x. All right, so let's just clean it up the way it's written. Typically we would do the 4 and then that piece and then the I, and there's our simplified piece. Okay, wonderful. So let's continue on. Take a look at our second slide. Now we're going to work with operations. So when we're adding and subtracting complex numbers, notice these are in the proper form, a plus bi. Okay, so when we're adding and subtracting them, what we would do is we would add the real parts together, and then we would add the imaginary parts together. So we've got the 3, and if you wanted to, you could write it out. I mean, you don't have to do this, but some people like to write the real parts out. So 3 together, 3 minus 6 plus 2. And then write the imaginary parts out together. 8i minus a minus, so plus 15i minus 4i. So that is a step that you could do if you wanted to. So now we just add the real parts together. So that would be what, a -1. And then we add the imaginary parts together, which would give us 19i. Okay, so there is that example of adding and subtracting imaginaries, or actually complex numbers. Now let's look at multiplying complex numbers together. And basically what we would do here is we would just FOIL. right? We would do first times first. So 4 times 2 is 8. And then outsides, 4 times a negative 3i would be a negative 12i. Inside, negative 5i times 2 is negative 10i. And then last, negative 5 times a negative 3 is a positive 15, and I times I is I squared. Okay, looking pretty good. Now let's clean this up. So I've got the 8, and then that's what? Negative 22i plus 15. Now what did we say I squared was? Yep, that's right. I squared is negative 1. So now continuing to clean up, I've got basically 8 minus 15, which is negative 7 minus 22i. And we have it in proper form, a plus bi. All right, very good. We're making progress. The last one, now this one is, we really, now let's write ourselves some notes here. Really important. We must rewrite first. No negative allowed under the radical. Okay, before we do anything else, we have to rewrite it first, because if we don't, then we're going to make mistakes. It's not going to turn out the way that it is supposed to turn out. So step 1, we rewrite, and then step 2, we're going to FOIL. So those are the steps that we're going to make. So let's rewrite first. So 2 minus, let's see, we've got this comes out as an I, root 3, and then 4 minus, and then we got that comes out of as an I. Okay, very good. So we did our first thing, we rewrote. Now we're going to FOIL. So 2 times 4 is 8. 2 times negative I root 3 is negative 2I root 3. And then that was, we've done this part. Now let's do, go here. So that would be what? Negative 4I root 3. And then here, negative I times negative I is a positive I squared. Root 3 times root 3 is 3. All right, so let's clean that up. So I've got 8, let's see, minus 2I root 3 minus 4I root 3 is a minus 6I root 3. And then we've got 3 times, and then we know I squared is negative 1. So let's continue cleaning that up, and that gives us 8 minus 3 is 5. So 5 minus 6I root 3. Whew, okay, great. All right, so we have one more concept to look at. And so this is imaginary. It's a complex number, right? I mean, we see it's got, you know, i's and stuff, but it's not in standard form. Standard form, we need it to look like a plus bi, right? We can't have it looking like that. So what do we do? I mean, what's our procedure when we come across a fraction with i's in, you know, the numerator and denominator, or one or the other? What are we going to do? Well, if it's a fraction with an I in the denominator, what we're going to do is we're going to multiply by the conjugate of the denominator. So I'm just going to remind you what the conjugate, so what is a conjugate? So let's just do a little sidebar over here. What's a conjugate? For example, let's see, so 1 minus root 2, its conjugate would be 1 plus root 2. Okay. Or say 5 plus 2i, its conjugate would be 5 minus 2i. And one other example, what about negative 2 minus root 3? its conjugate would be negative 2 plus root 3. Notice that the sign of the first number doesn't change. It's just this sign in the middle changes, but the sign between the two numbers changes. So that's just a little sidebar reminding you what a conjugate is if you didn't know, or if you knew, and if you didn't know, there you go, that's what a conjugate is. So here's what we're going to do. We're going to multiply by, and of course, I hope we remember we can't multiply by just any number. There's no equal sign there. It's not like we can balance an equation. We really have to multiply by the number 1. So if we're going to multiply by 5 plus I, we really have no choice but to multiply by 5 plus I over 5 plus I, because that creates the number 1, so we're not changing the value of anything. All right, now hopefully we can see that these, that we're going to have to foil the numerator and the denominator. That's okay, we can do that. All right, so 3 times 5 is 15. 3 plus 3i plus 4i times 5 is 20i, and then plus 4i squared. There's our numerator. Okay, let's work on the denominator. So 5 times 5 is 25. Then we have plus 5i minus 5i, and then negative I times I is negative I squared. Now the whole reason why we're multiplying by the conjugate of the denominator is so that we can get rid of the I. I mean, that's the major goal right there, is to get rid of the I down there, which we did. So let's clean this up. So we have what, 15 plus 23i plus, and we know I squared is negative 1 over 25 minus, again, I squared is negative 1. Okay. So let's see, 15 minus 4, what is that, 11 plus 23i over 25 minus a minus 1 is 26. Now we got rid of the I in the denominator, but it's really not in the a plus bi form. We really want it to look like this. And it's close, but it doesn't look like that. So what we're going to do is we're going to split this fraction up into two pieces. So we're going to finish this up by saying, so it's 11 over 26 plus 23i over 26. And that gives us our, and we can put the I up there or we can put the I here. I mean, either one is fine. That means A would be 11/26 and B would be 23/26. All right, great. That's our lesson on complex numbers.